get started, are there any questions over any of the assignments thus far? Any questions over any of the assignments thus far? Okay. Now what we're looking at today, at least to start off with, is this complex conjugate. So for any real, if we have a plus bi as a solution or part of it, its complex conjugate is also a solution, so a minus bi. So if we have a plus bi, we're also going to have a minus bi. Okay? So if a plus bi, its conjugate is a minus bi. A plus bi, a minus bi are the complex conjugates. So if we look at this one here, 7 minus I, the complex conjugate for it's going to be what? 7 plus I. Yeah. Yeah. So negative 5 minus i's conjugate is going to be plus 5i. Now there is something interesting that does happen if we multiply these two together. So if we multiply these two together, so we can use the distributive property, 7 times 7 is 49. 7 times I is going to be plus 7i. Negative I times 7 is going to be negative 7i, and negative I times I is going to be negative I squared. Bless you. Now we can combine the middle terms. 7i minus 7i, these would be cancel out. I squared is negative 1. And what is 49 minus negative 1? 50. Well, when we multiply these two conjugates together, all the imaginary terms cancel out, and we're just left with a real number. That's it. So the complex conjugate is this here, and their product is 50. If it asks for both, then yes. I mean, we could do the same thing with negative 5 minus 5i times negative 5 plus 5i. Now for this here, we could type it in. Negative 5 plus 5i times, well, times negative 5 minus 5i. And incidentally enough, we also get 50. That's not going to always work out that way, but it worked out with these two. And anytime we multiply the two conjugates together, we're going to get a number with no I terms. Questions on this here? So let's finish up the conjugate. So what would be negative 2 plus 4i? And if we want to find their product, we can just type it in and let the calculator do it, which is 20. And we could do, what's the complex conjugate of the next one? 3 plus 6i, which would be 37? No, 35. 45, yep. 16 and 9 would be 45. Or, sorry, 36 and 9 would be 45. 10 minus 2i's conjugate would be 10 plus 2i, which product would be 104. And the last one, negative 4 plus 8i, and I believe the product's going to be 100. Yeah, that makes more sense. Because it'd make, I was adding way too much. Because it'd have been, because negative 4 squared is going to be 16. our 8 squared is going to be 30 or 64. 16 and 64 would be 80. I was thinking of 36. Questions on these here? Now for this here, we want to write this here in standard form. And to do that, we need to get I out of the bottom of the fraction. We can't have I in the denominator. And to do, or kind of get rid of that, we're going to use the complex conjugate. So we're going to multiply the top and bottom by this, 1 plus 2I. Because as we just saw, multiplying the complex conjugates together causes the denominator to become just a number, or just to be, when those are multiplied, they become a number. So here, when we do the multiplication, we can do 1 times 1 is 1. 1 times 2I is going to be plus 2I. Negative 2I times 1 is negative 2I. And lastly, negative 2I times 2I is going to be negative 4I squared. Now the middle terms, 2I minus 2I is going to cancel out. And here I have 1 minus 4. Well, I squared is negative 1. Well, that's going to make that positive 4, and 1 plus 4 is 5. So that gives us a denominator of 5. But we still have to multiply the numerator. 4 times 1 is 4. 4 times 2I is going to be plus 8I. 3I times 1 is going to be plus 3I. And lastly, 3I times 2I is going to be plus 6I squared. Well, not always. We're using 1 plus 2I because the denominator of the other one is 1 minus.
So you would use the bottom?
The conjugate of the bottom.
But opposite?
Yes. Yeah, because since the complex conjugates, when they're multiplied together, all the I terms cancel out, and that's what we're trying to get at. So we look at the denominator of the first one here, 1, well, let me write in a highlighter. The 1 minus 2I, and we take its conjugate, which would be 1 plus 2I. And we multiply top and bottom by that, because, well, 1 plus 2I over 1 plus 2I is just 1, so we're just multiplying by 1. So it's not changing the value, but it is changing how it looks. Now we can add these middle terms together, which is going to give us plus 11I. Well, I squared is just negative 1, yes? So really we have negative 6. 4 minus 6 is negative 2 plus 11I over 5. Now we'll break this up to get it into standard form, which will tell us that it's 2/5 plus 11/5 I. Yes, so we'll look at that next. Any questions on this here? So the fraction is alpha y equals enter. Alpha equals enter. Okay, so try it again. Alpha y equals enter. So the next one we have is 1 minus 4I over 2 plus Yep, this one's a little bit nicer. So what we have to do is do it a little bit differently. Now, the fraction is really just saying we're dividing the two. So what we can say is 1 minus 4I divided by 2 plus 3i. We get that typed in and hit enter. Now it gave us a decimal, which is fine, because what we can do at this point is hit math, enter, enter, and it'll convert it back to a fraction. So the answer for this here is negative 10/13 minus 11/13. And that's the answer. Questions on these here? So if we look at the next one, we have a denominator of 4i. So we could still do this in the calculator. So we'd have to do 2 plus 5i divided by 4i. When you type 4i in, you do need to put it in parentheses. And we can do the same thing, math, enter, enter. And it'll tell us that the answer is 5/4 minus 1/2 I. Any other questions on this here? 5/4 minus 1/2 I. Is that what you got? And that's it. Any other questions on any of this here? Way too many copies of this homework. There we go. That's just an extra sheet. That's it. That's all we're doing for today.